Hey, everybody. What's up? All good? Okay, right. What we have done, guys. So we have covered all the basic part of the BGP protocol, right? Like we have seen the how to form the BGP membership, indirect membership, direct membership, and even we have seen that eBGP and IBGP behavior. We have seen the concept of the network statement and the neighbor statement, right? We have also covered the IBGP split Trojan rule behavior, right? Router effective formation and the confederation, and also we have seen the peer group, and we have seen also how to use the authentication in the BGP protocol, and then how we can prevent the loop in the eBGP as well as. Now, the most important topic right today is what? It's a path manipulation. That's a very, very important topic of the BGP, and most of the questions are coming only from the path manipulation, right? If I talk about the path manipulation in the any IGP routing protocol, if you have a look in the RIP protocol, in a RIP protocol, how do you manipulate the path? Path manipulation, first of all, understand the concept. What is the meaning of path manipulation? For example, router 1 we have, router 2 we have, router 3 and router 4. Understand? So basically what happened, this is my 10 meg link and this is my 5 meg link. So normally my best path should be the 10 meg, of course, right? But due to the some requirement, I need to change this path from not this way. I need to send my traffic from this way. So that's called a path manipulation, changing the default behavior, right? So in a RIP protocol, if you want to change the path, what do you have to do that? You need to change the hop count, right? That's a metric of the RIP protocol. Or that's a recommendation. Rather, you can go with the offset list too. In the RIP protocol, you can change the AD value as well. In EIGRP, if I talk about, we have a delay and bandwidth. That's a key values. And then we have also as an offset list as well, right? And then you can also change the AD values, and based on the summarize, and you can also manipulate the path in the EIGRP protocol. Then if you talk about the OSPF protocol, in OSPF, what happened? We have a cost over there, right? So changing the cost, what can be path manipulation requirement? So I just say that now it's based on the business requirement. For example, understand the concept. So this is my 10 meg link. That's my best path. And what happened? I need to change this path to the 5 mega link over there, because maybe I feel that there is a some packet drop is getting on this particular link. Okay, so maybe there is a delay over there, or there is a congestion on this particular network. I'm not changing the path from this way because I feel that this network is this path is good right now. So changing the default behavior. The same concept we have seen in the EIGRP protocol and OSPF as well, right? How to do the path manipulation. In EIGRP, if you remember that, Buja, we have seen the concept of the
Yes,
delay and bandwidth and offset list, right? Same thing is over. So in the OSPF protocol, if I talk about, we have a cost over there, right? So change the cost. And of course, we have a path preference. If you guys remember that, right? That EO or the OIA, right? Then E1 is equal to E2, and sorry, E1 is greater, sorry, E1 is more preferred than the E2, and then of course, N1 is more preferred than the N2. Same thing, if I talk about the BGP, right? In a BGP protocol, we have a lots of ways to manipulate that. So the main reason, right? The another main reason to switch the BGP protocol, if you compare with the IGP one, because IGP is not a scalable protocol. IGP, whatever the IGP protocol we have, RIP, EIGRP, OSPF, even the static route, if you see that, these things are not scalable on the internet side, because on the internet, what happened? We have a lots of things to manipulate the path, right? We have multiple ways. If you want to go from the one side to the another side, we have a multiple ways. If you just have a look over there, let me show you. This is, let me open my Google Chrome. And if you have a look, this diagram, internet, and go in the image. And let me go that down a little bit. Yeah, have a look at this image right now. So if you see, this is the, assume that this is the one of the router we have, this is another router we have, this is another router we have, this is another router we have, multiple routers we have. Can you see that? Multiple routers. So if you see from one location to the another location, right? From one location, from this location to the this location, if I'm assuming this is the source and this is destination, I have a multiple path. I can go by this way, I can go by this way, I can go by this way, I can go by this way as well. Do you really think that IGP is able to manage this big network? No. That's why this is the another reason why we are going to go with the BGP protocol, because in the BGP, what happened? We have multiple types of attributes. We have a multiple types of attribute, and based on that type of attribute, we can manipulate the path. So if you have a look over there, the first attribute we have in the BGP protocol is what? The first attributes we have is a weight. The weight is the first attribute. Then second, we have a local preference, right? Third, we have a locally originate. These are just a name, guys. Don't worry about that. We'll explain everything. And then the fourth one we have is the ace path length. If you remember that we have seen this attribute in a eBGP loop prevention. Then after that, we have a origin code, right? So basically we have three types of origin code of E. That's going to represent that EGP protocol we are not using nowadays. Then we have a I, that's going to represent that incomplete. And then we have a question mark, that's going to represent that it's not I for the IGP, and question mark for the incomplete. I'm so sorry. And I for the IGP. This IGP doesn't mean that it's a IGP routing protocol. Then after that, we have a MET, the metric we can call it, this is the metric of the BGP. Then we have a eBGP over iBGP, of course, because eBGP has a 20 ED if you compare with the iBGP. Then after that, we have a shortest path to the next hop. So every BGP routes has a next hop, right? Then we have a oldest path. Then we have a lower route ID. And then we have a lower neighbor IP address. So these are the attributes we have in the BGP protocol. And based on this attribute, right, a BGP can manipulate the path. These are just a basic one. If you go with the higher label, right, and I label, you will see the multiple types of attributes as well. Even in the route reflector that you have seen that, in a route reflector itself, we have a two attributes. One is called as the originator ID, right? And another is called as the cluster ID. But again, depend on the, like, syllabus to syllabus. If you go in the higher level, you will see multiple. Even if you go with the service provider label, you will see the BGP is like ocean. Okay, so in a BGP protocol, right, you have a multiple ways to manipulate the path. We have this range if you compare with the any IGP protocol. That's a beauty part we have. That's why we say that BGP is a much scalable routing protocol if you compare with any other one. Now, before I'm going to explain all these attributes right now, you need to understand the basic fundamental of the flow. Take example. This is my router number one, right? This is my router number two. Understand, if you understand this concept, then your BGP attributes will be done. Router one, router two. We have router one. This is router number two. This is the 12.1. Right? This is the 12.2. Okay. This is the 0/0 interface. And this is the also 0/0 interface. Right? So we have a network 2.0.0 over there, right? /8. So understand this way. When the router number two, right? When the router number two say that, understand this, we have a BGP neighborship. When router number two say that router BGP number two, I say the network 2.0.0.0, right? What happened? Router two is going to advertise the route. When router two is going to advertise this route to the router number one, for the router number two, this interface will become the outbound. This interface will become the outbound. Okay. For the router number two, this interface will become the outbound. When this is called what? This is called as an update. This is called as what? This is called as the update packet that router 2 is sending to the router number 1 /8 update, or we can call as a, this is the call as a control plane as well in a high level language. When router number 1 will receive it, what router number 1 will, guys, please pay attention of this diagram, because it's very, very important to understand the BGP attributes. So when router number 1 will receive this update, what router 1 will say that, hey, for me, because I'm receiving it, I will say that it's an inbound update. Okay. Now, once the router number 1 will receive this update, what he will do that he will update this routing table as a 20 will be 80, because I'm considering it's a eBGP. Then next hop will be 192.162.12. Sorry, 10.1 or 12.2. Right? Now what happened? Now router 1 say that, hey, I have a route in my routing table. Now I can send the traffic. I can say the ping 2.2.2.2.2.2. The source will be, could be anything, right? X.X.X.X.X. Destination will be 2.2.2.2.2. When this packet comes to router number 1, what router 1 will do that? Router 1 is going to look up the routing table, right? Based on the routing table, he will forward the packet to the 12.2, right? How do I get to the 12.2? It will do the recursive lookup, right? We did the recursive lookup in the static route, if you remember that. Looking the routing table multiple times for the one route, because we don't have exit interface in the BGP table. Oh, sorry, in a BGP route. So when the router 1 will receive this packet, what router 1 will do that? Now it's going to send the packet. So when he's going to send the packet, what he will do that? He said, hey, for me, this is my traffic. I can call this guy a data plane. This is the traffic that I'm sending, right? Where we have a source IP will be x.x.x.x, and the system will be 2.2.2.2.2.2. That's my packet. So for router 1, on this particular interface, what I call this guy? R1 traffic. When router 2 will receive on this particular interface, what I call this guy? Inbound traffic. Guys, does anybody has any question? Is it clear?
Hello. Can you repeat it? Repeat it, sir.
So when router 2 is going to send this update packet, it will be the outbound update. We can call as a control plane. When router 1 will receive on this particular interface, it will call as an inbound update. Router 1 is going to install this router in the routing table. Now router 1 is going to send the packet to the 2.2.2.2. It's called as outbound traffic. When router 2 will receive it, it's called as inbound traffic. Understood?
Yes, sir. Sir?
This is clear. The thing is contour plane and data plane.
Right.
That's what
so basically, control plane is what? Control plane is what? We are sending the routing information, routing update. That's your control plane. All your routing update, like OSPF, EAGRP, even if you are doing the ARP process, right? That's comes in the control plane. Creating the routing table, it's called as a control plane. Creating the structure is called as a control plane. Now, once the structure has done, once the network has set up, now what do you have to do that? You need to send the traffic. When the traffic you're going to send it, that's called the data plane. And whenever you're going to take a telnet or SSH of this router, that's called as a management plane. So basically, we have a 3 planes on the router side. One, we have a management plane. One, we have a control plane, right? And one, we have a data plane. So management plane is only going to deal with the telnet or SSH, right? Through the management plane, we are going to manage this device like a configuration. Through the control plane, what happened? We are going to set up the routing table, right? And through the data plane, now I can send the traffic. Now it's clear, Firoz?
yeah. Now clear. Thank you.
So if this point is clear, guys, this inbound update and outbound traffic, right, then everything will be clear. I'll tell you one more thing about this guy. If your update is a outbound, if your update is a outbound, then traffic will be inbound. Sorry, yeah,
Opposite direction, sir.
sorry,
Opposite direction, sir.
opposite direction, that's all.
Sir, I have one doubt, sir.
Yes.
Suppose, sir, R1 send any update to the R2, sir.
Again,
Means
same
R1
way, same way. Take example, if the R1 has a 1.0.0.0/8 update, then what we call this guy? When R1 is going to send this guy update, so it will call as a outbound update. Then R2 will say the inbound update, right?
Okay,
Now
sir.
R2 will send the traffic to the 1.1.1, then it's called as a outbound traffic and inbound traffic. Understood?
Yes, sir. Sir, suppose, sir, I am talking with you, sir. Means I am outbound, sir. If you receive anything, this is inbound, sir.
Right. So if you are sending to me, so for
Okay,
you,
okay,
it's a
clear, sir.
outbound. For me, it's a inbound.
If, sir, I want to communicate, suppose, sir, Bangalore to Delhi, sir. So from Bangalore, if I want to provide any information to Delhi, that is outbound from my side, sir.
Yeah, you are in the Bangalore, right? So you are sending the
Yes, sir.
traffic to the Delhi.
Yes.
So that will be outbound, and when Delhi will receive it, it's called as the inbound.
Okay, clear, sir. Thank you, sir.
Now, the most important thing is what you have to understand. You have to understand the control plane. Always remember one thing. Always remember one thing. You are only gonna deal with the control plane. You are always manipulating the control plane. You are always manipulating the control plane behavior. If your control plane is changed, automatically your data plane will be changed. If your control plane will be changed, automatically your data plane will be changed. Always you are manipulating the control plane. There is some scenario, right? There is some scenario in the advanced level where you can manipulate the data plane as well. It means that, so default behavior is what? You are forwarding the packet based on the routing table. So whenever you're gonna change the behavior to the data plane manipulation, because always you're gonna manipulate the control plane traffic. But when you change the data plane traffic, that's scenario is called as a policy-based routing or traffic engineering as well. Nowadays, it's called segment routing, advanced level, very advanced level. But you do have ability, you can also change the data plane traffic as well, right? But normally, always we are manipulating the control plane behavior. Now have a look. So if I talk about in this attributes, right? So we have a weight and local preference that you can see then the top one, the weight and local preference. These two attributes we have. Is used to manipulate inbound update. Right? It's gonna use to manipulate the inbound update. If you want to manipulate the outbound update, then you have to use the MET and ACE path. So we can call this guy as well like this way, understand? I'm understood this is a little bit confusing. You need to watch the video at least 2 times, then you will understand this thing, because there will be lots of theory, there will be lots of command line. So weight and local preference is used to manipulate the inbound update, or we can say that what? Outbound traffic. Because update is just opposite of traffic, right? Same thing, outbound update, inbound traffic. So in an interview, how you will encounter the question? So interviewer will ask the question, hey, tell me one thing. I want to manipulate the inbound traffic, or I want to manipulate the inbound update. So if they will ask you to manipulate the inbound traffic, so then you need to say that we made an ACE path. And if they will say that inbound update, then you need to say that wait and local preference. Very logical, but very, very important. I'm telling you, the 99% people are failing only in the BGP path attributes. When they give the interview in the company, 110% you will encounter this kind of questions. Okay, so let's have a look. Let's understand the first about the flow right now. Let me open my lab. BGP path attributes. Okay, so I have two different companies, Cisco and Nokia. So let me do one thing. I'll remove this guy. And I'll remove this guy. Okay, so I'll call this guy as AS123, AS1. So understand this is router number one. That's my AS number one, right? That's my Cisco company, right? And we have two different service providers. So, right, AS number two, we have router number two, and AS number three, we have, right? So let me power on the devices and let's do this lab. Notepad. And I already have a pre-configuration, so I'll better to write this over there. So router BGP number one. So you can see that IP address is already there, right? So I'm not going to write the IP address. I'm just going to configure the BGP over there. So let me show you the IP address first of all. So that's my plan, how I'm going to configure. So ACE, once the Cisco company has a connectivity with the Nokia via the two different service provider. So I can service provider one, that's my ACE number two, and service provider number two, that's my ACE number three. So two different service provider we have. So meantime, I'll just write on the service provider one. No, just wait. Okay, I'll take a different color. Below is fine. I'll take this guy's service provider two, SP2, SP1, and I'll say that this guy's a SP2.
Tarun Jain Capellini.
Okay, Tarun, I'll call you in some time. I'll call you in some time. I'll call you in some time. So service provider one and service provider two we have, right? All good. So let me. Little tricky topic, but yeah, it's a very, very important. So when you go with the I label, then you will have multiple attributes you have. Even the CSAT SP has a different label things. So if you see the IP address right now, so IP interface brief, I have a 12.1 and 13.1, and then we have a two loopback that's belong to the server 5 and server 6. And I'll say the no router BGP. Let me remove this guy if I have. So IP interface brief, so IP protocol summary. I don't have any protocol enabled. I have a loopbacks over there and my interface on R4. On R2 as well. So IP interface brief, so IP protocol summary. I don't have any protocol. I just have a basic IP configuration. On R3, if you have a look over there, so IP interface brief and so IP protocol summary. I just have a IPs and nothing else. What I can do now, I'm going to do the BGP now. So can anyone help me with the configuration of the router one? Anyone would like to configure the IP router BGP configuration on router one? Okay, no issue. As the neighbor will be 12.2, or remote AS will be as the 2, and as the neighbor will be 30.3. Remote AS will be 3, right? On our router number 2 right now, router BGP number as the config terminal. Someone mic is on, guys. Please be on mute. Router ID will be 2.2.2.2. Neighbors will be 12.1. remote AS will be 1, and neighborship, I'm going to make this as a 24.4. That's a remote AS will be 4. Right? On our router 3, we have our config terminal. BGP3, BGP router ID will be 3.3.3.3. Neighborship, I'm going to make this guy 13.1. Remote AS will be 1. Neighborship, I'm going to make this guy as a 34.4. Remote AS will be 4. Router 4 we have router BGP number 4. BGP router ID will be 4.4.4.4.4. Neighborship, I'm going to make this guy as a 34.3. Remote AS will be, of course, 3. Neighborship, I'm going to make this guy the 24.2 and 2. I have a network that's the 4.0, network 44.0, and network 172.16.1.0. That's my classless route. So I need to use the mask keyword. All done, right? So let's configure it. Router 1. Router number 2. Router 3. Router 4. All done. So router 1, you can see that router 1 has formed the 2 neighborship with the router 2, and router 3, we can say that SP1 and SP2, right? And R4 also should form the neighborship with the SP1 and SP2. So Cisco has a neighbor relationship with the service provider 1 and service provider 2, and Nokia also has a relationship with the SP1 and SP2, right? Now, if you see that one thing on a router 1, by default, if I talk about the maximum path of the any of the routing protocol, if you see the EIGRP, OSPF, even the ISS protocol, RIP protocol, the by default maximum path on the Cisco iOS router is a by default 4. It means that router can do the equal cost load balancing. Router can do the equal cost load balancing, right? That's a default behavior of the any IGP routing protocol. But if you took a look about the BGP has a by default, the maximum path is 1. That's a default behavior. Doesn't matter if you're using the eBGP and iBGP. It means that router 1 cannot, the BGP cannot do the load balancing by default. It means that when router 4 is going to advertise this particular route, understand the concept, always remember, you are setting on the Cisco side. Okay. So when router 4 is going to advertise this route to the router number 2 and router 3 as well, this route. Router 2 can also share this information to router number 1 and router 3 as well. Also. So in that case, what happens? By default, the maximum path is 1. Router 1 can either accept the route from the router 2 or router 3 because of the maximum path. Right? So if you see right now on a router 1, the maximum path do show IP protocol, right? It's only 1. And that's the reason BGP by default does not perform any kind of load balancing. That's a default behavior. It doesn't mean that we cannot do that. We can. Next thing is what? If you see the routing table right now, that's for the eBGP and iBGP AD values, right? If you see the routing table, so IP BGP, you will see the route I'm receiving from the both the ways R2 and R3. Can you see that? 4.0 from the 13.3 and 12.2. 44.0 from the 13.3 and 12.2. I'm sitting on the router number 1, guys. Please pay attention. And 172.16.1.0/24, 13.2 and 12.2. Which mod I'm making the best? 12.2. So if you check the routing table, I have a 12.2. I don't have a 13.3. Now the question is, why 12.2? Why not 13.3? So what happened? Understand the concept again. So whenever the BGP router will receive the route, what BGP will do that? BGP will perform the scan operation. BGP will do the scan operation. First, it will look for the weight. What BGP will do that? Understand the concept. There's a BGP guy over there. What this guy will do that? It will look the routing table, or we can say the BGP table if you look at that. And in BGP table, it will find who has a higher weight. So if you see from both the side, right? From both the side, the weight is what? 0 from both the side. Higher weight is always preferred. Higher weight is always preferred. Default behavior, if I talk about, right? For locally originated route, the weight is 32768. For learned route, the weight is 0. How much I can change on the Cisco iOS router? It's a 16-bit of number. You have a 1265535. This is the range we have to change the weight. Another thing is also remember high level. It's a locally originated. Not locally originated, it's a locally to the router. It means that if I'm going to configure on the router number 1, I cannot save the weight to the router number 2. That's the meaning of locally to the router, like a AD value. Administrative distance, the AD value is a local to the router. If you're going to configure the AD on the router number 1, it cannot save to the router number 2. Same way, the weight is a locally to the router. If I'm going to configure the weight on router number 1, the maybe 100, I cannot save the weight to the router number 2. That's the meaning of locally. Another point about the weight is what? It's a Cisco proprietary.
Hello.
Yeah.
Sir, it means, sir, only, sir, we can configure in R1 weight.
Hello? Yeah, tell me, go on.
Hello.
Yeah, I can hear you, Saurabh.
Yes, sir. Sir, my question is, only when we configure weight, only we can configure in R1 router, sir.
If you I'm saying that if you configure the weight on the router number 1, it
Yes, sir.
cannot share the weight information to the router number 2. If you configure the weight on the router number 2, I cannot share this weight information to router number 1.
It means it's locally configured in router 1, sir.
Right, it's locally configured on the router number 1.
Yes. Thank you, sir.
So the weight, if you see that, what I told you, the first thing is the weight is what? It's a locally to the router. And second thing is what? For the learned route, it's a 0. So if you see that, router 1 is learning the prefixes, right? Router 1, these prefixes are learning. That's why the weight is 0 over there right now. But if you check on the router 4 is advertising this route. So in the router 4, what happened? If you see I'm advertising this route, the weight will be what? 32768. Okay, so the weight is the first thing is the weight is what? Weight is tied. The reason is tied because from the both the direction, what happened? The weight is coming as a 0. So weight will be tied. You are sitting on this guy on router number 1. Then it will look for the local preference, right? Local preference. Local preference is again what? Local preference is a higher preferred. Right? Again, if I talk about this guy, it's a IEEE standard. It means that you can go with the any vendor. Either you have a Juniper, if you go with the Huawei, you have a Dell, anything. But weight is a Cisco one. Second thing is what? The LP, the default LP is 100 on a IBGP route. It's local to the AS number. Local to the AS number in the sense of what? If I'm, for example, router 1 we have, router 2 we have, and router 3 we have. Right? And if understand this concept, so router 1 and router 2 is a part of the same autonomous system of AS number 12. And this is belong to the AS number 3 right now. So if I'm going to configure the LP 100 on this guy, LP 100 on this guy, I can say this information to whom? Router 2. But I cannot share the router 3 because it's a local to the AS number. Whereas if you remember the weight, the problem with the weight is what? If you configure the weight 100 on the router number 1, I cannot share this weight to the router number 2. Higher LP is more preferred. Again, in that case, what happened if you see in this behavior, both this guy again, you are on the router number 1, both the router 4 is advertising this route to the router 2 and router 3, and router 2 are going to advertise this route to the router 1, and router 3 also advertise this route to the router 1. What happened? Same LP, nothing is there right now. Again, it will tie. So weight is tie, LP is tie. The third point is what? It's a locally originated. But right now, if you see, according to the R1 perspective, it's not a locally originated because I'm learning this route. If I'm learning this route, can I say that it is a locally originated? No. It's not a locally originated route, right? Because we are learning the prefixes from the neighboring router. You are setting on the router number 1. Then again, it will tie, this tie, then it will go with the AS path length. If you see from this side, router 1 will receive this route via the AS path 2 and 1. And from this side, router 1 will receive the route from the AS path 3 and 1. Both have the same range, 2 and 2. Again, it will tie. Then it will go with the origin code, right? Again, we have 3 types of origin code. You can see that E, I, and incomplete over there. E, this thing we are not using it nowadays because it was an older protocol. So in the 1970s, what happened before the BGP, we had a EGP protocol. On that time, we were using the E code over there. Nowadays, you will not see the E. Either you can see the IGP or either you can see the incomplete. So I is more preferred than the incomplete. For example, if your router is receiving the one route, 1.0.0.0 with the I code, and if your router is receiving the 1.0.0 route with the incomplete code, router 1 is always give the preference to the I code. So when you advertise the route, guys, when you advertise the route through the network statement, when you advertise the route through the network statement, then you will see origin code as I. When you redistribute the route, when you redistribute the route, then you will see the origin code will be incomplete. The question mark. So right now you can see that I'm advertising the route through the network statement. You can see, and that's why from both the side, what happened? I will get the code is I. If you see the code over there, that's our origin code. If you see the code over here, the I code, if you remember that in the last video, we have discussed this thing, then it means that the route is belong to the IGP protocol, IBGP protocol. The route is belong to the IBGP protocol. So we have 3 types of origin code we have. Again, in this case, what happened? The code is tie, right? Because both the side we are getting the II only. So again, what happened? We have to go with the next one, the metric of the BGP. By default, the MED will be 0. And from the both the side, what happened? You can see the MED is what? Empty, 0. Empty means 0. So again, what happened is it will also tie. Then it will go with the eBGP over IBGP. So do we have an IBGP over there? No, it's pure eBGP. So again, what happened? This will also tie. It will look for the shortest IGP path. Do we have any EIGRP OSPF protocol over there? IGP means OSPF EIGRP? No. Again, it will tie. Then it will look for the oldest path. This is the tiebreaker of what? eBGP protocol. So oldest path means what? To whom I first form the neighborship. To whom I first form the neighborship. Take example, right? If I first form the neighborship with the router number 2, if I first form the neighborship with the router number 2, and then I form the neighborship with the router 3, then it will become the oldest one and it will become the new one. So right now you can see that. So IP root BGP, the 12.2 is my oldest path. If I'm gonna right now, because the 12.2 is the older one, right? But take example, what happened? If I'm gonna shut down this particular neighbor, then router BGP number 1, I say the neighbor will be 12.2 and shut down. So if I'm gonna shut down this guy, then what happened? This neighbor is down. And if I'm gonna no shut down, then again, then what happened? It will become the new and it will go with the old now. Right? So if you see router 1, do show IP BGP now again, what you can see that 13.3 is the best now. If you check the routing table, this is happening because of the oldest path. So the tiebreaker for the eBGP is what? Is the oldest path. So again, if take example, if I'm going to shut down this particular neighbor, 13.3 down, shut down, then what happened? And if I say the no shutdown, then 13.3 was older. Now what happened? This neighbor came up, right? So it will become the new. And automatically what happened? It will go with the older this one. So again, the older is more preferred. So that's how this is the last tiebreaker for the what? eBGP protocol. This too we'll discuss, don't worry about that. Hold on. But now what I want that R1 should always give the preference to whom? R1 should always give the preference to the router 3. Right now, R1 is giving the preference to the router 2 right now, right? It means that I'm getting the route from this side. So is it an inbound update or outbound update? Tell me. For the router 1 perspective, again, you have to always think about the router 1 perspective because you are the sitting on the router number 1. You are network engineer sitting on the router number 1. You have to think about the router 1 perspective.
Inbound for router 1.
It's an inbound update, right? Or we can say that outbound traffic. So for the inbound update, if you want to manipulate the path, which attributes I need to use it?
Wait and local preference, sir.
Right? So let's do the wait first of all. What I can do that right now? Right now, the 12.2 is the best path. And the wait is default is what right now? The wait is default is 0, from the both the side. If you see. I can configure the wait is what? 1 over there. 1 is more preferred than the 0. So right now the 12.2 is best. I'll make this guy as a 13.3 is the best. I'll configure the wait is 0, 1 this side. So I just need to go on the router 1. Let me put this configuration in the notepad.
So if the weight is 0, that means it is a preferred as a
It's
bus route, right?
wait 0 is the locally originated, not learned route. I think so. You joined late, Nasir.
Yeah, yes, yes. That's right.
So I'll say the Nebo to whatever the route that I'm receiving from the 13.3, I'll configure the wait is what? It's a 16-bit of number. I said the what? Anything you can do that. I said the do clear IP BGP is strict soft. And here we go. So now the weight is what? 1. So if the weight is 1, then what happened? I'll give the preference to this guy. Higher weight is more preferred.
Good.
So all the best path is now what? Previously, the best path was a 12 or 2, R2. Now the best path is R3. For all the route, it means that I cannot utilize this path anymore. If this link goes down, then I can go via this way. But if this link up, I cannot utilize this particular link. That's a one problem. So if you remember that we did the practical in the EIGRP offset list too. I do have ability, what I can do that, for the certain route, for the specific route, for the certain route, I can say that, hey, please go via this way as well. So let me remove the weight right now. Let me try to understand this thing. I'm going to remove the weight. This is not a command. This is just to send the refresh message. Now what I can do that, though I have removed the weight now. So weight is default. So it will look for the oldest path now. So the oldest path is 13.3 right now. That's why I go with the oldest one. What I want now, I'm going to change the weight for the sum route. I'm going to say that, hey, 13.3 is the best right now for all the route. Let's do one thing. For the sum route, I'll say that, hey, I want to get the 4.0.0 from this way. And remaining 44.0 should we go via R3 only. So in that case, what happened? I can utilize both the link. So the default behavior is what? R3 because of the oldest path, right? I will change the weight for this guy. So how do I do that? You need to create the access list for a specific, change the weight for the specific route. I say the access list, one format. I'll say the route map, Cisco format. That's a sequence number, match IP address. In the IP address, I call the ACL number 1 and say the set weight is what? I'll make this guy at 30,000. Exit. I'm gonna allow the remaining route from this neighbor. I say the router BGP number 1, neighbor SIP. I say the 12.2 route map. Is it an inbound update or outbound update? It's an inbound update. I will say the in. So 3 steps we have. Step number 1, we need to match the route. Match the interested route. Right? Step number 2, call the ACL and define the weight. Third is what? Apply it. That's all. So if you go to the, let me make a comment, comment and comment. And now I'll copy and paste it. Somewhere I did a mistake. Okay, not a big deal. Now, if you see the do show IP BGP for this particular route, hold on. Correct. So only for the 4.0.0, I'm changing the weight. Remaining, all this guy will go with the default behavior. Whatever the default, maybe the R2 is the default behavior or R3 will be default behavior, like oldest path. So you can now see that I'm changing the weight for the only for this particular route. Hold on, it will become the best. What does the configuration on each router in real-time scenario? Could you explain that, please? Boozer, in the real-time scenario, on each router, you have a different type of configuration. It's depend on the requirement. BGP is a big ocean, but 110% you have a path attributes. If you have connectivity with the multiple service providers, or if you have a multi-homing scenario, then always you have a path attributes. But like if you give me the one, like output of the any of the BGP configuration, I'll explain you. But it's totally depend on the scenario, right? What I can, like, I have seen the multiple ways. So if you give me your company scenario, I can explain you. Let me pause the recording. So now you can see that. So I've changed the path. You see that? So only for the 4.0.0, the weight is 30,000. For the remaining route 44.0, 70, 172, 16 or 1.0, the weight is 0, normal. But still, these guys are getting from what? 12 or 2 because of the oldest path, nothing else. Not a big deal. Right? So if you want to make this guy 13.3 is the best, then what you can do that? I can shut down the neighbor for the some time, then it will become the 13.3 as the best. Wait a minute. All good. So for this guy, this is the best. For the remaining person, R3 is the best. All good. This is all over the weight, guys. 2 ways to change the weight. One, you can apply to the neighbor directly, and you can change for the specific route. Second attributes that you have, right? For the inbound update again, you have a LP, local preference. So why do we need to use to LP? Because weight is a local to the router, right? If you want to change the complete autonomous system number, then you need to go with LP. For example, you have a topology like this way right now. So I can say that AS number 1, 2, 3. So it means that your router 2, router 3, and router 1 is a part of the same autonomous system number. And I want to change the path for the complete autonomous system, not for the router 1 only, and not for the router 2. I want to change the path for all the autonomous system number. In that case, I need to use the LP. Weight is a local to the router. Right? So let's go with the LP now. So for the LP, what we have to do that we need to change this configuration. So I'll say that no router BGP number 1 right now, because I need to make this guys to play like this way. 2, 3, 4. So I'll copy this configuration from here, and I'll paste it. So the router 1 should be router 1, 2, 3. 2.2.2.2. It's 1, 2, 3. It's 1, 2, 3. All good. This is also 1, 2, 3. This is also 1, 2, 3. This is R4. All good. All done. All done. R3. What I did mistake. Route of BGP number 1, 2, 3. Okay. R2 now. R3. R4. All being all right. Now, in that case, what happened? Try to understand one thing. When router 4 is going to advertise this route to router 2, and router 4 also going to advertise this route to router 3, right? Router 2 is going to share this information to router 1. So whenever R2 is going to share this information to the another IBGP neighbor, it will never change the next hop. So you will see the 4.0.0.0.0 with the next hop will be what? 24.4. Same thing from this side. 4.0.0.0. Next hop will be what? 34.4. So do you have a reachability of this next hop? If you check on the router number 1, you don't. Can anyone tell me what is the solution for this guy? I don't have it out in my routing table. Can anyone tell me what is the solution for this one?
Next hop self.
Next hop self, right? So I need to go on the both the router. I need to go on the router number 2 and say the neighbor 12.2, 12.1, please change the next hop. And same thing on the router 3. Any other solution do you have, guys? I haven't discussed, but do you have? It's a part of the CSI, so you can advertise this link into the protocol. Sometimes it's not a recommendation, sometimes it's recommendation. It's totally depend on the scenario. Now R3 as well, please change the source next hop. So whenever I'm going to advertise the route to the R1, instead of using the next hop of R4, please use my next hop. Now you can check on the router 1. I got the router. In changing the next hop. So now the R2 is making the next hop is 12.2 and R3 is making the next hop is 13.3. But which one is preferred now? 12.2. Why? So in case of eBGP protocol, what IBGP protocol, what happened? Now the oldest path is only for the eBGP. When IBGP comes in the picture, then it will look for the lowest router ID. Who has a lower router ID? R2 has a 2.2.2.2, R3 has a 3.3.3. So R1 is looking at the lower router ID of the R2. If I'm going to make the router ID of R2 is a 200.200.200, then what happened? Then R1 is going to make this R3 as a best. Then R1 is going to make R3 as a best because lower router ID is always preferred. Now you can check on the Lucio IBGP. Hold on. You will receive the route from the R2 as well. Little bit slow protocol, so you need to have a good patience level when you do the BGP configuration. I remember, I think I told you that, right? I troubleshooted one of the network, I think it's a long time back, 5 months back, and I found there was a 1 million of the router in the routing table. And the issue was from the customer end is what they was asking, hey, why the routing table, right? The BGP table was taking almost 5 to 6 minutes to update the BGP table itself. So that was the problem. Now you can see that I'm making R3 as the best because of the lower router ID. And you can see the LP is now comes in the picture. That's the IBGP. That's the default is LP is 100. I mentioned that if you see. But take example, what happened if you have one scenario like this? So now you understood, right? Lower route ID. So if I'm going to change the route ID of the R2 again, I said the BGP route ID will be what? 2.2.2.2. Then again, router 1 is going to make a preference to the router 2 because router 2 has a lower route ID compared to the R3. But take example, what happened if you have a same route ID? So if you have this scenario, then you have a 12.0 network, 12.1 this side, or maybe the 1.1, and maybe the 1.2, and maybe the 2.1 and 2.2. So I'm getting the route from both the side, right? Then which one I'm going to make it? Because route ID is same from both the update. So R2 is updating the 20.0.0 and 20.0. So both has the same route ID. Which one R1 is going to make the best? In that case, lower neighbor IP address. So R1 is going to make the 1.2 as the best one. So when the router ID get tie, then it comes in the picture of the lower neighbor IP address. So R1 is going to make the 1.2 as the best one, not the 2.2. If you have this scenario. So now what I can do that for the inbound update, I'm going to make a preference to the inbound update. So I'm setting on the Cisco side right now. And what I want, R3 should become the best one. What I can do that, I just need to go on the R3 and change the default behavior, BGP default local preference. So 100 is by default, you can see that. From both the side, from the router 2 also advertise the 100 and this also advertise the 100. I'll just go on the R3 and say, hey, listen, make a 1000 from the R3 side. Then what happened? R1 is going to make the R3 as the best. You can see it's a 1000. So this way you can change the path by changing the LP values. But again, the problem of this one is what? It's gonna change for all the routes. So if you see, R1 is gonna make the R3 as the best for all the route. Because of the LP, because I'm advertising the LP from this side is 100 and this side is 1000. So what happened? Higher LP is more preferred, right? So in that case, what you can do that you do have ability, you can change for the specific one as well. Same command, nothing is different. You just need to copy and paste it. I'll say the 4.0 network ACL, and I'll say the instead of the weight, I'll say the local preference. And I'll say the again, it's an inbound update, right? Because we are changing for the inbound update as the 34.3, 34.4 route from Cisco in. So I'll first remove the LP and I'll refresh this guy. So R1 is gonna make the normal behavior right now. Now I'll go on R3 and change this guy. Okay, my mistake. It's 1, 2, 3. So now you can see what happened only for this particular route. Which route? I'm changing the LP values. So now you can go and check the routing BGP table. Only for this particular route, what happened? I'm making the R3 as a best route. Right? So whenever router 1 is going to send the traffic for the 4.4.4.4, my traffic will go by this way. Right? So whenever the router user sitting behind the router number 1 or Cisco users, when trying to access the Nokia server number 1, it will go by this way. And all the remaining traffic will go by the default behavior. like a 44 and 172.16.0. Right? So that's a way that you can change the LP and wait. So both are for the inbound update. But take example now what? So let me remove the LP now. Right? So everything is normal now. Yep. Now take example now what? So this is all over the inbound update, right? But take example now what outbound update, because you don't have a control on the Nokia side because you are sitting on the Cisco side, right? You don't have any control on the Nokia side. You are only going to manipulate on the Cisco side. Now on a Cisco side, I have a few dots, 1.0 and 10 dot network. So let me advertise this guy as well. Okay, router BGP number 123 network, right? So if you see now router 1 is going to share this information to whom? Router 2 and router 3 as well. Router 2 is going to share this information to router 4 and router 3 also going to share this info router 4, right? Router 4 will receive this information. I'm just taking a one example, right? 1.0.0.0 and 1.0.0 from both the side. What router 4 will do that? Can anyone tell me which one router 4 is going to prefer? R2 and R3? Anyone? So in that case, what happened? It's an eBGP connection. For the eBGP, what will be the tiebreaker? It's the oldest path, right? So R4 is going to depend on the oldest path. He's going to make the any one of the best. So if you check the BGP table, I say the BGP table saying that for the 1.0 network, 24.2 is the best route. And for the 10.0 network, 34.3 is the best one. Why is doing that? 1 minute, guys. Do we have any policies configured? Anything? Anyways. Hold on. Nothing is there. Nothing is there. So let me refresh this guy. Let me reset the new web. So R4 will receive the route from the both the base. So now do show BGP. Hold on. So on a R4, these are the locally originated out. For the locally originated out, what happened? The next hop will be 0.0.0 and the weight will be 32768. It will take some time. BGP is a little slow protocol. So yeah, patience. Yeah, all good now. So you can see that 1.0 I'm getting from the 24.2. Perfect. And the 10.0 also getting the 24 because I'm assuming that R4 is assuming that the 24.2 is the oldest one as compared to the 34.3. So what I want now, because I only have a control on the Cisco side, right? So what I can do that now I'm going to manipulate the what? Previously, I did the manipulation of the inbound update. Now I'm going to manipulate the outbound update. And for the outbound update, what attributes I have? For the outbound update, I do have a MED and AS path. So what I want right now, understand the concept. What I want right now, R2 is the best path, right? I want, R3 should become best. So what I can do that, the default metric, you can see that's a 0 from both the side, right? And as we know that lower metric is always preferred, right? You can see that I mentioned over there. Did I mention? No, let me mention. So lower MET is always prefer used for outbound upbeat manipulation, right? Same way, lower AS path is always prefer used for outbound update manipulation. Right, so let's do the med right now. So lower, right now you can see that from both the sides is 0. What I can do that, because right now R2 is the best, you can see that. I'm gonna advertise the med from this side is what, 100. Matrix is 100, so of course lower will be preferred, right? So 0 will be become the best one. So I'll just go on the notepad and configuration, and I'll say that MED, change the med, LP. So I just need to change the route now. I say the 1 or 0 or 0. And if you want to change for the all the route, you can change for the all the route. So let's do the for the one route only. So I'm gonna make this guys only for this particular network 1 or 0. I'm gonna make the med is 100, right? And for the 10 or 0 or 0 or 0 or 0, the med still will be 0, right? So it in that case, what happened? Understand the concept. In that case, what happened? So from this side, right, it will advertise as a med is 0, and this side advertise as a med is 0, right? So R4 is gonna make the 1.0 or 0 network as a R3 as the best because of the lower met. Because from this side, I'm getting the higher met for the 1.0 or 0, right? And for the 10.0 or 0, you can see the both the side the met is 0 right now, right? It will go with the anyone, which is the default behavior. So that's done. I'll change this guy as a set metric is maybe the 5005. And I'm going to apply it. So on a route 2, I'm going to say the 24.4 because it's for the outbound update. So I'm going to say that out. That's all. So now you can check on the route 4 now. So previously I had no med. Now you can check. I have a med 5005. So for this network, what happened? I'm getting the med from the 5005 from the R2 side. I change the 5005 now. And from this side, I'm getting the 0. So of course, I'm gonna make this guy the best for the 1.0. And how about the 10.0? So 10.0 is coming by the default behavior, which is the R2 because of the oldest path. So you can see, even if you check the routing table right now, do show IP route BGP. What happened? So whenever the router 4 is going to send the traffic to whom? 1.1.1.1. Cisco will receive the traffic via the R3. But whenever the router 4, or we can say the Nokia, will send the traffic to the 10.0.0, Cisco will receive the traffic via the router 2. All good? This is happening because of the MED. Same way, you also have another behavior alternative option you have. You have an AS path. AS path is always lower prefer. Remember one thing, MED and AS path is lower prefer for the outbound update. Wait and looker preference is a higher prefer for the inbound update. So let me remove the MED now from the R2. So I'll say that now what? Let's change the behavior of the AS path now. So understand the concept again. So from the both the side, what happened? We are getting the route, right? So from this side, if you see that the when R2 will advertise, it will advertise as a AS path 1, 2, 3 and AS path 1, 2, 3. From this side also, I'm going to advertise as a AS path 1, 2, 3 and AS path 1, 2, 3. So right now R4 will make anyone will become the best one, maybe the R2 and R3 because of the depend on the oldest path behavior. So if let's have a look, which one is the oldest path right now. So 24.2 is the oldest path and 24.2 is the oldest path for this network. Because 1.0 and 10.0 is belong to the Cisco right now. Cisco has a 2 server, the 1.0 and 10.0. R4 is gonna make the 1.0 as the best one. Sorry, R4 is making the R2 is the best path to go in this network. What I want now, again, same behavior. I'm gonna make this guy as I want to make the 1.0 R0 as a best for this. So whenever the router 4 is going to send the traffic to the 1.0 network, right? So when R4 will send the traffic to the 1.1.1.1, R3 should prefer. And when R4 will send the traffic to the 10.10.10.10, R2 should prefer. How do I do that? Same behavior. So lower AS path is more prefer. What I can do that from this side, I will increase the AS path 1, 2, 3 and 1, 2, 3. So how many AS path I'm getting from this side for the 1.0 network? Only one. How many AS path I'm getting from this side? 3 AS path. So I'm gonna make this guy the best. And for the remaining 10.0.0 network, it will go by the default behavior. So let's match this route 1.0. I'm gonna say that set AS path prepend. I'll say the 1, 2, 3, 1, 2, 3. That's all. All done. Let's go on route 2 now. Here we go. So now you can check on the route 4. So for the 1.0.0 network, what happened? I'm making the R3 as the best because of the lower AS path. This should be not a best because of the higher AS path. How about the 10 now? Because for the 1.1 R3 is the best now. For the 10 now, if you see, it's go by the default behavior, 24.2, which is the oldest path. So that's how you can change or we can say the manipulate the route in the BGP table. So BGP allow you different flavors. We have different ways to manipulate the path. So you have a ability to manipulate the inbound update or outbound update as well. Doesn't matter. You are in the Cisco or not, right? So if you have a control only on the Cisco, you can manipulate both the path. You can manipulate the inbound and outbound as well with the help of BGP, which is normally not, I can say, that impossible. You need to do the lots of tricky things in the IGP routing protocol. Understood, guys? Good. So that's all about the BGP. It's not all about the BGP. We have something few things are left. That's a basic part like BGP states and BGP masses type, we can call it, or we can call as a packet types, right? So this will we see on the maybe on the Thursday. The reason is a Thursday because today I'm traveling to the Delhi. Okay, so tomorrow or I'll talk to the Puneet. So maybe tomorrow or day after tomorrow. So Puneet will take care of your batch for the automation. He will take care of you and the wireless part as well. I'll save this notepad. So, Copy and all done, guys. Anybody has a questions?
So is there any more class for the BGP?
Yeah,
That's
that's
it?
one more day, Thursday.
Okay, one more to go. Okay,
Yeah.
no problem. Okay, that's fine.
Yeah, sure. Chalo, guys. I'll see you tomorrow. Bye bye. Not see you tomorrow. See you
Thanks.
Thursday. So tomorrow, or maybe the day after tomorrow, we'll take care by the Puneet only.